Misha has a cube and a right square pyramid, which are made of clay. She placed both clay figures on a flat surface. Select each choice that identifies the two-dimensional plane sections that could result from a vertical or a horizontal slice through each clay figure. Well, let's start by bringing in some diagrams that can assist us with this problem. So we have a cube and we have a square base pyramid. So we're going to figure out what type of two-dimensional figures result from a horizontal and vertical slice of this figure. So let's start with the vertical in both of these cases. So if I was to do a vertical cross-section of this cube, and I can do a vertical cross-section of this pyramid, and they can intersect the base wherever they would like. So I made the bottom line be my marker for the cross-section. So we have a square for this one, or more broadly, a rectangle if we need it. And then for this one, the vertical cross-section here is straight across and then up and then back down to make a triangle. All right, so a cube cross-section is a triangle. Okay, this is for vertical. So can any of these be named as true? Let's see. A cube cross-section is a triangle. Well, not yet. A cube cross-section is a square. Yes, that is definitely true with what we have drawn so far. A cube cross-section is a rectangle, not a square. Not sure yet. The right square pyramid cross-section is a triangle. Yes, that one is true. Right square pyramid cross-section is a square. Not sure. Right square pyramid cross-section is a rectangle or not a square. Okay, not sure about those yet. So far we have two, and those go with the vertical cross-sections that are drawn this way. Okay, so let's try to redraw cross-sections in a different way. Let's try horizontal cross-sections. And horizontal cross-sections usually look like a parallelogram when they're drawn here. Okay, so here's one, and when this one intersects the cube, it's going kind of like this if it aligns with the front. This also looks like a square, so that still goes with two. And if we were to take this and bring it over to the pyramid, and we cut it so that right here is the bottom of our cross section corresponds here, then we would go up, across, and down. This one, because it's a square base pyramid, we know that this one has to be a square. So all of those are going to be square. So that gives us this one as well. Now because the square base pyramid, whenever you cut it horizontally like this, you're always going to get a square each time, just of different side lengths. It will never actually become a rectangle. It's not possible with this part. So 6 is completely ruled out. We know that the cube cross-section can be a square when it's both horizontal and vertical. I wonder if there's a way that we can draw a cross section in the cube to make it a rectangle. So let's try to do that. So what if we did a vertical cross section of this cube in this direction, and it went this way? Is this going to be a square or a rectangle? Well, because we already know that this edge and this edge and this edge are the same and they're right angles, I know that this side across from the right angle will be longer in length. So it will not be the exact same length as these edges. So these two sides of the cross section will be the same, but the top and bottom will be different. So that means that you can have a cube cross section that is a rectangle and not a square. So options 2, 3, 4, and 5 are all possible here. It's not possible to have a cube cross section that's a triangle when it is horizontal and vertical only within those cross sections. So the answer here is D. And if we actually look at these diagrams, they are drawn better than what we were doing before. So here you can clearly see that here's the square, here's the rectangle that I just tried to draw here, here's one triangle, but you can also go vertically side to side and still get a triangle, and then here's the plane that's intersecting the pyramid to form a square cross section. So again, the answer here is D.